2.3, Analyzing Rational Functions for Oblique and Horizontal Asymptotes. So we're going to be determining when you have a horizontal asymptote and when you have an oblique asymptote and where those asymptotes will be. So the first thing is determine a non-permissible values and asymptotes, sketch the asymptotes using graphing technology, and then state the domain. So we can tell from this equation that we have no holes, because we can't cancel anything. We have a vertical asymptote at what makes the bottom 0, so x equals -4. So let's sketch that in. So -4, we have an asymptote. Maybe I'll tell my asymptote joke, but maybe later. Who knows? Okay. I want you to type this equation into Desmos and see what it looks like. So pause the video, type this into Desmos. So what you should have found is that your asymptote, it goes like your graph, oops, maybe I'll do it a different color. It goes like this. Up over here, and then kind of like this over here. So you can tell then that there's an asymptote at the axis. So there's a horizontal asymptote at y equals 0. So the reason why there's a horizontal asymptote at y equals 0 is because if we look at this equation, if f of x, okay, so we have f of x over g of x, if f of x is smaller, so if it's less, the degree, sorry, I should have explained that. If the degree of f of x is less than the degree of the function of g of x. So right here we have a degree of 0, and right here we have a degree of 1. So it's less than. So if the top is less than the bottom, then you're going to have a horizontal asymptote on the axis. So that is our first type of asymptote. So the top smaller than the bottom. Okay, this question. So let's check to see if the top is smaller than the bottom. The top degree is 1 and the bottom degree is 1. So they are the same. So this is when f of x and g of x are the same. That's what we're dealing with. Okay, so we have no holes, but we will have a vertical asymptote at x equals 1. So I want you to pause the video, and I want you to type this into Desmos, and I'm going to draw this asymptote in at 1. So what you should have gotten on the video, or on Desmos, is a graph that looks like there's an asymptote at 2. And the graph goes up like this, and down like this. So we have an asymptote at 2. So horizontal okay, so the reason why is if I look at the leading coefficients of these two, so I have 2 for my leading coefficient on the top and 1 for my leading coefficient on the bottom. So if f of x and g of x are the same, you're going to have a horizontal asymptote at a ratio of the leading coefficients. Wow, I said that weird. So ratio of the leading coefficients. So if it's less than, you have it at 0. If it's equal, leading coefficients. Now I bet you are understanding that the next one is going to be if it's greater than. And when we're talking about greater than, it's always going to be when we're greater than by 1. So this one is a degree of 2 and a degree of 1, so the top is greater is greater than g of x by 1. Okay, so we know that f of x is greater than g of x. And then what that is going to give us is it's called an oblique asymptote. And you'll see what that means when we type it into Desmos. But we do also know that there are no holes, and there's a vertical asymptote at x equals -1. So go ahead, type this into Desmos. So what you should see when you type it into Desmos is it's definitely going away from this, but you should have it going like this, and then like this, kind of. And the reason for that is because there's an oblique asymptote right here. So oblique means diagonal. So I'm going to show you how to find the oblique asymptote, the equation of the oblique asymptote. So what you are going to do is you are going to use synthetic division, and you're going to divide the top by the bottom. So we're going to divide by -1, and then on the top it's just x squared, but remember you need placeholders. So it's 1x squared plus 0 plus 0. So we're going to bring down the 1. 1 times -1 is -1. -1 plus 0 is -1. And then the last one actually doesn't matter. The remainder doesn't matter, because this part right here, what you're left with when you divide, is your oblique asymptote. The remainder doesn't matter because it's so insignificant. It's pretty much 0 as you approach infinity. So we have an asymptote, oblique asymptote, at y equals x minus 1. And I tried to show that in there, but it's kind of not done well. So yeah, that's your oblique asymptotes. So let's put this to use. Write the equations of any asymptotes and verify using graphing technology. First step is always find the factored top. So two numbers that add up to 6 multiply to make -7. Our numbers are 7 and -1. So we have x plus 7, x minus 1 over x plus 2. So first of all, f of x is greater than g of x. So I know I'm going to have an oblique asymptote. So we'll do that second. Let's do the other stuff first. So we have no holes, but we will have a vertical asymptote at x equals -2. So there's that. Okay, now let's do our long division so that we can figure out what our oblique asymptote is. So the top, so 1, 6, -7, divided by the bottom, -2. Bring down the 1. -2 times 1 is -2. Add those together, you get 4. We don't care about the remainder, but our oblique asymptote is going to be at x plus 4. So there are our asymptotes. So this one and this one. So to sketch this before we even type it into Desmos, we know we're going to have oblique asymptote at -2. I mean, a vertical asymptote. My bad. And we're going to have a oblique asymptote at x plus 4, which has a y-intercept of 4 and a rise over run of 1. So you should be able to graph this perfectly. Oops. So draw that line in. Okay, there's our asymptotes. Love them asymptotes. Got two big ol' asymptotes. Okay, sorry. Type this into Desmos. What you should see from Desmos is it looks like this. And it looks like this. So there's your graph. Let's do our domain and range. So our domain, we know that it cannot equal -2. And our range is going to be everything. Alright, next example. Let's factor. So I want you to pause the video and I want you to factor the bottom. And you really shouldn't have had to pause the video because it's the same one as the last example. So x plus 2 over x plus 7, x minus 1. Okay, so we have no holes. We have a vertical asymptote at x equals -7, at x equals +1. I know that f of x is less than g of x, and when f of x is less than g of x, I have a horizontal asymptote at y equals 0. Okay, let's sketch all of our asymptotes in. Oh my gosh. Okay, so we have it at -7. That's lovely. And 1. And we can't really sketch in that 0 because it's right on the axis. So pause the video, type this into Desmos. What you should have found is it goes like this, and then it goes like this. No. Let's move closer. Like that. And it goes like that. So it's just a sketch. So our domain is x cannot equal -7 and 1. And what you should notice here is that it did cross the asymptote. That is okay. It happens with horizontal only. You can never touch a vertical asymptote, but those horizontal ones, they want you to touch them. It can happen. Not always, but sometimes. You just have to ask and see if it looks like it's right. Alright. That's that one. This is a long lesson. Okay. We're going to do 2 more examples. So for each graph, determine non-permissible values, equation for horizontal asymptote, domain and range. So same thing we just did. So we can factor this one. We can factor the top and factor the bottom. So we have x minus 4 over x plus 4, x minus 4, 2. It's a 2, not a 4. Square root both of those things. So we have no holes. We have vertical asymptotes at 2 and -2. So let's draw that in. Okay, there's one. Oh my gosh, I'm so bad at this. And there's another. Okay, we know that f of x is less than g of x, which means we have an asymptote on the horizontal axis, so y equals 0. Okay, now type it into Desmos. It says with graphing technology. So pause the video, graph it. What you should have gotten is in this area it goes down. Same with this area. And then in this one it goes like that. So for our domain, actually, this one over here comes above the axis. It's more like this. Okay, so our domain is x cannot equal -2 and 2. Our range is everything. Opulence. You own everything. There we go. Alright, there's our equation. Okay, next one. Factor the top, factor the bottom. Now, what you might notice about the bottom is that it is 1 subtract x squared. So what I'm going to do is I'm going to divide that by -1 so that I can write it as x squared minus 1 instead, because then I can write it as x plus 1, x minus 1, which will match the top a lot better. I want you to pause the video and factor the top. You should have got the top to be x plus 3, x subtract 1. Okay, this one has a hole. So we haven't had a hole in a while. So hole is at 1. We need to find the equation of or the coordinate of the hole, so we're going to use the equation that has been simplified, and we're going to plug in a 1. So we have y equals 1 plus 3 over 1 plus 1, which is 4 over 2, which is 0.5. So the equation of our hole is 1 and 0.5. That's good to know. All right, we also have a vertical asymptote for this one right here. So at x equals -1. I also can see that f of x is equal to g of x, which means that we're going to be doing a ratio of the leading coefficients. Oh, don't forget this negative right there, which I forgot to write. Oops. Oh my gosh, what's happening? All right, there should be a negative there. So our leading coefficients are 1 and -1. So we have a horizontal at y equals -1. All right, so -1 is our horizontal. We have 1 at -1 for our vertical. And we know we have a hole at 1 and 0.5. So that, oh my gosh, this should be a -0.5 because I forgot this. There we go. So it should be right here. I can't really draw it. Okay, so pause the video, type it into Desmos. What you should see is that the graph goes like this, and like this, touches the hole, and then if you go on Desmos and you hover over where that hole is, it will say undefined. That's how you can check. Alright, solving a rational equation graphically. Again, not my favorite way to solve things because you're better at math than this, but sometimes it will just ask you to do it graphically. So the thing that you're going to do is you're going to move everything to one side. So we're going to subtract x from both sides, and then you're going to type this into Desmos. And what you are looking for is the solution, which is, of course, the x-intercept, or seps, if necessary. So I've done that already. Here's our answer. So x equals 1.834. And that's all, folks.